Welcome to the Home and Energy Chats webinar episode on offsite construction for high performance homes. My name is Heather Chandler and I'm the owner and publisher of Green and Healthy Maine Homes. We have a fantastic presentation for you tonight and I am looking forward to learning with you. So I would like to start by thanking our sponsors. Special thank you to our season sponsor, Senecal Construction Services. They are now offering net zero ready design build packages in Pownell, conveniently located just minutes from Portland, Freeport, and Brunswick. And also a word from our presenting sponsor this year, Royal River Heat Pumps.
Hi, I'm Scott Libby, owner of Royal River Heat Pumps. A long time ago, the Royal River, like most rivers, was an important part of life, powering mills and allowing a community to grow and flourish. Nowadays, we see what a river can help to create. We believe that ordinary people can come together to make a big difference too. This year, Royal River Heat Pumps will invest our advertising dollars into a new campaign we've launched called Ripple to River. Each month, we'll choose a different nonprofit organization whose focus is kids battling childhood illnesses. We'll tell you about their particular mission and let you know how you can help support them. We're also launching an online resource at rippletoriver.com, providing information and a link for donations. Little things can turn into big change. I'm Scott Libby from Royal River Heat Pumps in Freeport, and I hope you'll join us in making change happen for kids and families that are facing challenges that nobody ever wants to face. Visit rippletoriver.com to learn more and donate, and thank you.
Thank you to both of our Home and Energy Chat sponsors. Want to share a quick overview of how the evening is going to flow. We will begin the webinar with a presentation from each of our three panelists, and then we will have time after the presentations for Q&A. We did receive several questions through the registration process, some really good ones, so thank you. And if you do have additional questions that you would like to share with our panelists as you listen to the presentations, please feel free to add those in the Q&A function at the bottom of your screen, and we will do our best to get to all of them. A reminder that the webinar is being recorded this evening and will be uploaded to our website, greenmainehomes.com, later this week. So if you have to jump out a little early, there'll be an opportunity to catch that. If you are not familiar with us, Green and Healthy Maine Homes is a media company dedicated to inspiring healthy, efficient, and future-ready Maine homes through a quarterly print magazine, the annual Green Home and Energy Show, which we just had in April, and save the date, we've scheduled for April 6th next year. We have an online business directory, monthly email newsletters, and an active social media presence where we share expert advice to inspire healthy, comfortable, efficient, and sustainable Maine homes. So please check us out at greenmainehomes.com to learn more. And now it is my pleasure to introduce our panelists. Parlin Meyer is the director of BrightBuilt Home, a design firm in Portland that engages offsite construction manufacturers to facilitate the building of its modified and custom high-performance home designs. Under her guidance as director, BrightBuilt has added more than 200 high-performance homes to the built environment across New England and the Eastern Seaboard. Parlin leads development of new designs, optimization of processes in offsite building, and identification of best practices and materials for creating healthy homes. So welcome, Parlin. Next up, we have Mark Hertzler, who is the director of Unity Homes. He has spent the majority of his career in the home building industry working on residential new construction and renovations. He's been with Unity Homes for the past 5 years and hopes to spend many more years as part of the effort to build better homes. Welcome, Mark. And last but not least, we have Amelia Tracy, who has worked on high-performance home design and construction, renewable energy, sustainability policy, and regenerative land management projects in almost every corner of New England for the past 15 years. At Geologics, she is responsible for community building through sales and marketing, as well as health, safety, and inclusion role, which promotes diversity, equity, inclusion, and belonging work as an ally. So welcome, Parlin, Mark, and Amelia. At this point, I'm going to turn it over to Parlin, who is going to kick off our presentations.
Thank you, Heather. And thank you everyone for being here tonight to learn about offsite construction. It's my pleasure to share with you our perspective and our insights in specifically the realm that we occupy in the offsite construction world, which is the world of modular. So in order to convey some information and share some of our story, I wanted to start with a little bit of a breakdown. Sorry. I'm going to share initially just a little bit about who we are, where we're located, what we do, and how we're structured. Then I will touch briefly on, what is modular? There's sometimes some confusion in the offsite world about what that means and what that looks like. So I want to talk about that briefly as well. I want to touch on why I'm saying modular can be mighty. How can modular be mighty? So I'll go into that. And also just talk a little bit about where there are opportunities for modular specifically for that approach. And then wrap it up with why it is we build net zero, why that's important to us as a company. So I'll start off with who we are. So yes, we are a company based here in Portland, Maine. We're comprised of a team of earnest souls who are really invested in this mission to deliver high performance homes. And we are structured largely as a design firm, but we have set things up to engage with the offsite manufacturers and engage with general contractors in a way that really helps facilitate the entire process from start to finish. So we have a portfolio of pre-existing designs, and as designers, primarily, we engage with our clients in order to modify, adapt, and create essentially unique homes for them based out of our base home portfolio. But I can say in over 250 designs that we've done in the last 10 years, only 2 of those homes have actually been based on our base models. So, by offering that flexibility and offering the opportunity to adapt the home to exactly the needs of the homeowner and the site, it allows us a lot more flexibility while still engaging in the offsite construction model. So, where we've largely been in recent years in this freestanding single family home realm and sort of more traditional 1,500 to 2,500 square foot range for most of our homes. More recently, we've seen certainly an uptick in interest and more development of the accessory dwelling unit realm and marketplace. So we've been developing a lot of designs around the accessory dwelling unit market, and certainly for homeowners, there's a lot of appeal in engaging with offsite construction and engaging with modular, in that you get this largely completed structure delivered to your home, making much lesser of an impact to your home, your lifestyle, your day-to-day, as you build out new structure and add value to your property. So in summary, our mission as a company is to enable rapid delivery of attainable high-performance homes by tapping the existing infrastructure of offsite construction. So we're a company that works to facilitate design and set these infrastructures in place, but we are not ourselves a manufacturer. We're working within that existing infrastructure to deliver these homes. In short, our goal is really to make an impact fast, make an environmental impact, make a meaningful impact on the lives of our homeowners, et cetera. So really that's our goal, and that's what is at the base of the development of this company and the launch of this line of homes. So moving then into what exactly is modular. Well, just to give a quick overview on typical offsite construction of the last 50 to 100 years in this country, we have that pre-1976 mobile home, which is what many people think of when they think of manufactured or offsite construction. They think of these mobile homes, or what came after 1976, when there was a regulatory push to do better, build better for this, the offsite construction market of the lower income bracket, was the HUD manufactured housing. So there's that style home. And then there's, of course, panelized. And I'm going to defer to both Amelia and Mark to speak to the panelized world in their presentations today. And then modular. So modular is that more nebulously defined approach that often gets associated with the pre-1976 mobile home or the manufactured housing realm, but is in actuality an approach to segmenting a finished single family home in a way that allows for the majority of it to be built offsite. And in the end, what you get is what appears to be a home that was built on site, and a home that looks certainly like all the other single family homes that we're familiar with. So functionally, most of the homes are broken into anywhere from 1 to 4 to 5 modules for typical square footages ranging from about 500 square feet to 3,200 square feet. Your standard home that we just saw in the last image there is broken generally into 4 modules. So you can see the 2 modules on the main floor and then 2 modules on the second floor. Those modules are all nearly fully completed off-site and then transported to the site and craned into place and assembled to arrive at that final finished structure. You can see on the right-hand side this image of what is a 2-module home, where it's the base module and then the roof module, which is in fact also fully roughed in, sheetrocked, mudded, painted, and finished on the interior, delivered as a module in and of itself and set down on that base on site. So just to break that out a little bit diagrammatically in some of the other images we've already seen, this home on the upper left-hand corner is comprised of 4 modules. On the right-hand side, it's 2 modules. And the difference between those functionally is that what you get with the left-hand side is fully finished second floor, so that the space above in that attic is either unconditioned attic space or could certainly be finished, as is the case in this home, a finished attic loft space with additional living square footage. Whereas in this more Cape style home, where you have effectively a single story or 1.5 story home, you have the main modules delivered from the manufacturer, and then the completion of that attic space is done on site. So the interior partition walls, the interior finishes are completed in that upper level in this instance. And then the lower 2 images are further examples of a smaller home delivered as a single module and a larger home delivered as 5 modules. So that's just kind of a diagrammatic breakdown of these homes that, by all appearances, look like they were built on site, were in fact segmented into these different modules and delivered to their sites and completed in the finish out on site after they arrive. So really, this is one of the reasons that, we certainly embrace modular, and where modular to us makes so much sense is that you get a lot of the home substantially complete before it's ever even shipped from the manufacturer. All the sheetrock is installed, mudded, painted, all the windows are installed and trimmed, and the trim is painted with a finish coat of semi-gloss white. You get really a very, very close to done home before it ever leaves the factory. So you get to have those advantages of bulk purchasing. You get the advantages of the efficiencies of the integrated manufacturing process. And then certainly you have a lot less to do after things arrive on site. The other advantages, and this applies of course as well to panelized, is that you still have to dig a hole in the ground, you still have to excavate, you still have to put in a basement, crawl space, or slab. But you can do all of that concurrently with when the exterior shell of the home is being manufactured off-site. So overall, it shortens your time on site and shortens the required overall arc of construction. Then, of course, for modular, when the modules arrive on site, you go from a foundation to fully weathered in, dried in a single day. That's true for the vast majority of cases. There are a couple rare exceptions to that where the project is more complex or the roof line's more complex. But generally speaking, everything goes from open foundation to weathered in, roofed, and essentially fully assembled in a single day. And then, of course, as already noted, with much of the work being completed prior to the departure from the manufacturer, your finish out on site is also a shorter time frame. So there's a benefit to homeowners. There's a benefit to homeowners that might want to make a lesser impact or be less intrusive to their neighbors through the course of construction. The turnaround's faster from start of construction to completion. That has advantages when it comes to financing and construction loans. So, you know, a lot of arguments to be made, certainly for offsite construction. So how can modular be mighty? Well, for us, we have engaged these modular manufacturers with whom we work to ensure that the specifications and the performance of the home is aligned with our expectations and our predictive modeling and performance requirements. So we work with manufacturers who are willing to build a better envelope. We use double stud wall assembly and we use dense pack cellulose. So we have 10-inch deep walls, and we also pay a lot of attention to air sealing. So using tapes, sealants, caulks, all of the different things that are really going to make for a very, very solid, well-built envelope. We add to that, of course, which is standard in the high performance realm, better systems that are going to engage energy in a different way, have lower loads on the energy uses for the home, and be more efficient. So air source heat pumps for heating and cooling, energy recovery ventilation for air exchange, bringing in fresh filtered air into the home, and also really allowing for that tighter envelope. And then, of course, also using air source heat pump technology for the domestic hot water supply. And then finally, again, with regard to the envelope, using better windows and doors, triple pane windows, really well sealing exterior doors, really paying attention to that envelope and working with manufacturers who are able to do the detailing and supply the materials that get at that high performance realm. So, so that's how modular can be mighty. And then finally, of course, the prep and follow through for the home is really important. So we do energy modeling for all of our homes to anticipate what the loads are going to be, what the potential solar array will be to get it to net zero. And then we follow that through by ensuring that there's commissioning and blower door testing happening. So where are there opportunities for modular? I'm going to move through this fairly quickly. New construction is the most common and perhaps obvious realm in which modular is really appropriate. So building a new home, bringing it to the site, assembling it and finishing it out, as was demonstrated earlier. And then also, of course, accessory dwelling units. It's really, like I said, it's hugely appealing to a lot of homeowners to have a very short turnaround from when the assembly arrives on site to when their first family member could move in, or when they could start to put it into service for themselves. Really short turnaround, very low impact on the neighborhood, high appeal in using modular and offsite construction approaches for accessory dwelling units. And finally, urban infill reconstruction. So whether it's a tear down and replacement of a home in an urban infill setting, or even in some instances, additions of modular assemblies on existing homes. So I will now wrap up with why it is we do what we do. Why build net zero? Well, the obvious answer to that, of course, and one that's certainly an overarching theme in today's market and world, is climate change. So as you can see from this graph, building operations and building materials and construction comprise 40% of the total global CO2 emissions. You could also argue that transportation and industry are contributors to building materials, construction, and others. So we occupy even a larger sector than that. So using materials that make sense, using technology that makes sense, and really gearing towards better homes for a lower CO2 emission impact is really important to us and our mission. There's also, just from a practical sense, the escalation of energy and electrical costs. So designing net zero homes has the benefit to the homeowner of lower energy costs and lower maintenance costs over the course of the life of the home. And then coupling that with the decreasing cost of solar, it ultimately proves out to be a no-brainer that if you're going to build a new home, you build it to be net zero, you build it to be high performance, so that you can really lower your energy demand, lower your energy costs, and take advantage of putting a solar array on your home and becoming effectively energy autonomous. So the other reason, of course, that we build net zero is for our homeowners. You know, these are extremely healthy homes. These are very comfortable homes. They're well loved by the homeowners that live in them. And, you know, doing the work that we do helps make an impact on their lives too. So building net zero is very powerful, not only for the impact it has on the environment, but certainly the impact that it has on the lives of our homeowners. So with that, I will say thank you very much for your time and hand things over to Amelia from Geologic.
Thank you, Parlin. It's really cool to see the slide about the history of modular. My folks built a place in the 90s that was modular, and I'm sure everybody in our family has heard about it way too many times, just in terms of the technology that it's advanced. So thank you. Hey, everybody, my name is Amelia Tracy. I am up in Belfast, Maine at Geologic. I've been here with Geologic for about 2.5 years. I started as a carpenter in the pandemic to learn a little bit about how to build. I have an architecture background and a sort of a high performance design and construction. Just can't get out of that industry here in New England. So it's really lovely to spend time this evening with you. Geologic, we're actually a 35-person design build firm these days. We have 2 panel shops, one here in Belfast and then the other one down in Scarborough, which is just outside of Portland. We were founded in the end of 2007, actually, by an architect, Amelia, and a builder, Alan Gibson. Alan is the sole owner of Geologic at this point, and this is his slideshow. So that's why you see his name in the bottom left. Cool. So Geologic, we got started in 2008 with the express intention of only ever building passive houses. So the red house in this slide shows the first certified passive house in Maine, which is actually here in Belfast. Since then, we've built, this is an older number, I think it's going to be closer to 140 homes this year throughout New England to date. Our territory is about 400 miles from Portland, sort of amorphous territory, but that tends to cover Hudson Valley, northern New Jersey, and then all of the rest of New England. So our mission is to design and build healthy, comfortable, low carbon homes that are affordable to a wide segment of the population. So what we do is for the majority of our projects, we bring people through a catalog of pre-designed homes on our website. There are 12 of the pre-designed homes under the Go Home tab on our website, and this is a portion of them. And they range from 2,300 square feet on the top end to 600 square feet on the bottom end. And what this catalog of homes represents is the first iteration of each of these designs that we ever did, but we've never done the same house twice. So when you call us and you ask, how much customization can we make to these plans? I tell you, as much as you want to, because the reality is nobody does the same thing twice. So this is some recent, this upper left-hand 1600 model is up here in the mid-coast. That was finished a couple of years ago. 1700 is also up here on the mid-coast. The Fortin residence down below was a winner of a Passive House Source Zero award, which has to do with how much embodied energy that the assembly of the building has, which was extremely low. In that case, the owners wanted to be as aggressive as possible. And the Eco Village on the bottom right was the first project that we built as a company, which is a co-housing village in Belfast with 36 multifamily units. So our process, we start everybody, so we have a 2-contract process. The first part is the design contract, where we work through site planning, design development, if we're starting with one of those pre-designs, and then we do structural engineering, and we run a passive house specific energy model during the design phase to design the energy load of the building and the mechanical systems that correspond to that. And then we work out the finishes and fixtures in the design phase. That phase tends to be about 6 months. And then we need a couple months when designs are finished to work out construction pricing. And then usually that's when a bank gets involved to do some kind of construction loan. And then during the build phase, if Geologic is not the builder, what we do is we contract for the shell at the same time as the client contracts with the local general contractor. And when we get the contract for the shell, that's when we order the German windows that we import. So the German windows are wood frame, triple pane, tilt and turn and aluminum clad windows. And they have about a 3 to 6 month lead time to come in. So when we're waiting for the windows and doors, that's when the site work and the foundation go in. And then once we have the shell assembly, once we have the windows in place, that's when we are able to build the shell in our shop. And then about 6 weeks after the shell is built, it is able to be delivered to the site and put together with a crane with our own carpenters. And then after the shell is assembled, a local general contractor will complete that shell on site. So why? We are bleeding heart environmentalists in this company. There's like a term out there about sort of a growing population of people who need to do professional work related to climate change. And that's really embodied in the community here. The other reason why we do panelization is because we're trying to work on what this graph is talking about, which is, as you can see, manufacturing, utilities, ag, and transportation, their productivity since 1950 has gone up, and construction's productivity has gone slightly down in that long, and we're working on solving that problem. So Alan, the owner, and several others from our team took a trip to Scandinavia and learned about manufacturing there and brought back best practices for how we do things. And so what we do is we're always optimizing our panel assemblies, size of panels, the actual assemblies, the detailing, so that the panelization process is as streamlined and as efficient as possible. We're working on a few updated pre-designs for our website that reflect our current best practices for panelization. And this is an example of the new 1600. And for all of our panels, we build 3-dimensional shop drawings, which is what the crew in the shop used to build the panel shells. Here you'll see this is a truss system on the roof where we've moved to a panel system, but our panels are exterior walls, interior load-bearing walls, ceilings and floor systems, and then roof systems. This is a picture that shows the window installed in the panels in the shop. And this is the air barrier sheathing layer on top of the structural wall assembly in the middle of this wall assembly is called the window buck, which is where the rough opening is that holds the window. And then on top of that sheathing layer in this photo, you can see the wood fiber insulation, which is on the outboard side of the structural wall. You can also see sort of in the stud cavity on the lower part where the table is, the gasket that connects each of the panels together. And so this is an example of our wall assembly with the structural framed wall on the left side with the gasket, and the exterior hemp fiber, I'm sorry, not hemp, wood fiber on the right side, which is where the siding would be applied to. This is a picture of, you can't see the crane, but what, like an example of what the first day would look like, assembling a shell assembly on site. And this might be the second day. And the crew are carpenters who travel to put the panels together. And then you can see the completed shell assembly on the left, and then the completed house on the right. So these are just some more of our finished projects. And some of our people. And then we're in the process of building a new shop facility that's going to 3x our production space and put our design team in the same building as our production facility, which is going to make it so nice to be one company, coordinating our details and communicating about just efficiencies and innovations. We're a company that really believes in continuous improvement, and the spirit of sort of research and development and innovation is very deep here. So being in one space and sort of finding our creative juices together as a team is just something that we're really looking forward to. So I think that's all I've got. And so I'll pass it over to Mark. Thank you.
Thank you, Parlin and Amelia. It's great to be sharing the screen with other people and companies that are just as committed to improving the way houses are built. So it's a privilege to be here. Unfortunately, going last, I feel like the two of you pretty much said everything that needs to be said. So maybe I'll just skip to some pictures of our houses. Anyway, I'm Mark Hertzler, Director of Unity Homes. Unity Homes was launched in 2012 as a spinoff of Bensonwood. Bensonwood is a company that Ted Benson founded in 1973 and is currently celebrating its 50th anniversary this year. So Ted first became known for his work in and authoring several books on timber frames. However, eventually Bensonwood became synonymous with impeccably crafted homes built to the high standards for energy efficiency and sustainability. Ted had always wanted to bring the same high quality and standards to a larger market, which is why Unity Homes was eventually formed. Unity's mission is to make the level of quality that Ted Benson made famous and the performance available to more people at a lower cost. Because Unity is built upon Bensonwood's extensive experience, knowledge, and innovation, we consider it to be a 40-year startup. By the end of this year, we expect to have reached almost 180 houses built since 2012. We believe that combining the deep knowledge of Bensonwood, the innovative technologies of offsite construction, and the pursuit of comfortable, healthy homes is a better way to build. Oops. All right. So what is it we're trying to do? As I mentioned, we want to build healthy and comfortable houses, just like everybody here. We're putting an emphasis on indoor air quality, using mechanical ventilation to bring in fresh air. With an airtight house, that's very important to make sure that you're getting that proper ventilation. We use low VOC materials to reduce off-gassing. We use triple pane windows to keep that comfortable feeling inside the house, no matter what the temperature is outside. We're energy efficient. Again, you know, with the houses being airtight and using triple pane windows, that adds to the energy efficiency along with the dense packed cellulose. And most of our houses, the R values in the walls are an R35 and the roofs are an R51 to an R60. We want to build sustainable houses. So we try to use materials and methods that have a low carbon footprint. And with offsite construction, we can minimize waste, and all of our houses are designed to be net zero ready. We want our houses to be resilient. They're engineered and designed to last a long time. Our interior, in the interior of our walls, we have what we call a service layer. So that separates the airtight insulated layer from the living layer. And that allows the houses to be adaptable over time and reduces major renovations down the road. And as has been mentioned, multiple times tonight with offsite construction, it's much more predictable than building on site. All of our panels are built in a climate-controlled factory and assembled on site within weeks, not months. So where do we build? In theory, we can build anywhere in the country, just about. In practicality, we build mostly in the Northeast, and that's due to the high shipping costs. So this is sort of a scattering of some of the houses that we've built. We have gone as far south as North Carolina and as far west as Wyoming. This is our panel factory in Keene, New Hampshire. It's about 110,000 square feet. And we've installed a solar array on the roof that produces about 2/3 of our electricity usage for that factory. So this is a picture of the inside of our factory. This is what we call our wall line. So most of the equipment you see here are computer controlled machines. So the machines in our factory do everything from picking up the materials to cutting it to labeling it. And then they're put on the wall line, which will go through and nail together the frame, place the sheathing on, nail the sheathing down, cut out windows and doors. Then that panel will be flipped over and it will be filled with dense packed cellulose. Then with another layer of sheathing installed, and then excuse me, our service layer on top of that. So we have a lot of computer controlled equipment in our factory. We still have a lot of people working in our factory to maintain that equipment and make sure that it is running properly. So once the panels are built in the factory, then they show up on site. They're put into place by cranes. You can see in this picture, and I think Amelia had pointed this out on her panels as well. On the right-hand side, there's the gaskets that help seal the panels when they're put together to create that airtight insulated shell. All the panels are bundled according to how they're going to be installed. So even before we start manufacturing any of the panels, our virtual fabricators will create panels and put those panels in the bundles. And those bundles will be built in a particular order so that they can be put together and then shipped to site in the correct order so that we can assemble them quickly. And again, typically a house like this would be all assembled and weather tight within 2 weeks. So our design system is based on what we call a base platform and then adding components. So we have 4 main platforms that we start with. And then as you can see in this 3D model, you have the ability to add components such as connectors, porches, bedroom suites, garages, and there are specific attachment points where they can go. But you have the freedom to attach whatever components that you want and essentially design a somewhat custom house using standard components. This is just a 2D representation of the similar thing with floor plans. So as you add components to the design, you have options for floor plans. And those can be mixed and matched to fit the needs. So just a few pictures of some main projects that we've completed. As I said, we've built houses in quite a few states, but Maine, we have a fair number of projects that we've built there. This is what we call our Zoom style house, which is a monopitch sort of modern style. This house was just recently installed this year in Bar Harbor. This again is our Zoom style, a little bit smaller on a walkout basement, and this is on Chebeague Island. And the same house from the other side with that spectacular view. And the inside of the house, again, with that view. And as you can see, as I mentioned before, our interior surface layer that is inboard of the air and air barrier and insulation layer, so that any plumbing and electrical after we install the shell can be run without penetrating that insulation and air barrier. This is another house that we built on Chebeague Island. The previous one actually just went up last fall. This one was built in 2017. That's the same house on Chebeague and the kitchen inside that house. This is what we call our Xyla. So it's a single story bungalow type house. And this one was built in Harpswell in 2020. And this is also a Xyla. A few other features with the expanded garage. And this house was built in Brunswick in 2018. This is what we call our barn, which is a sort of a modern farmhouse, 2-story design. This one happens to be on a walkout basement with a screen porch. And I'm sorry, this one was the one that was built in Brunswick. The previous Xyla was in Durham. So thank you for the opportunity to tell you a little bit about our company and participate in this event.
Thank you all for your wonderful presentations. I think you all did a really nice job of showing us the future of modular and really how far we've come from the modular homes that we may know from 20 years ago. So I think you've also done a really nice job of dispelling the myth that modular is cookie cutter. I think you both talked to you all talked to the customization options, which is really nice to hear. And I wonder if you could talk a little bit about materials choices and particularly how it relates to low carbon and embodied carbon interests. Who wants to go first?
I'm happy to touch on that for what we do. So the slide, or a few of the slides that I showed have like cut sections of our insulation detail. And I looked at wood fiber insulation, which has been our standard detail. We were importing it from Europe. There's a manufacturing facility of the same product coming online soon that we're excited about, but we've actually moved to hemp fiber insulation for our exterior insulation detail. And part of the reason for that is because hemp is a product that when it's grown is sequestering carbon and building soil. And it's a bio-based material, so that works for us. And the other half of our insulation detail is a recycled newspaper cellulose detail. So for us, embodied carbon is a really large part about how we decide on what to buy. And the sort of durability and performance ratings of those products are really good for us as well. So.
Helpful. Anybody else want to add anything to that?
I'll just add, can't follow Amelia with much more to add, because all the points you made are really critical. I think in general too, just wood frame houses with a cellulose or wood fiber based, natural based insulations and materials are a great place to start when you're really looking to minimize carbon impact and minimize your carbon footprint. There's other spaces in the realm of, trying to go with a slabless foundation, or places where you can reduce concrete, because concrete is a massive, has a massive carbon footprint. So, I think all of us are really looking at this question right now, and looking at opportunities for reducing carbon impact in the materials that we source and the assemblies that we develop for the homes.
That's actually a really great segue into several questions that we received during the registration process that had to do with foundations. So I'll share them here. Could you differentiate how you each spec and approach foundation insulation was one. Somebody else asked if your homes require a certain type of foundation. And then lastly, what strategies have you employed attaching a module to a foundation? And can you talk about any lessons learned?
Sure,
So
I'll start with.
Great.
I can start with that one. So for Unity Homes, we can build on any type of foundation. We often build on full basements, daylight basements, and slab on grade. If you can do slab on grade, it's great. As Parlin said, it uses less concrete, and concrete is the one material we would like to try to get away from as much as we can. But certainly there are sites that just require a basement, or especially a walkout basement. For Unity Homes, the way we handle insulation for the foundation is under any slabs, we're going to put 3 inches of rigid insulation for an R15. And we'll do the same on the exterior of the foundation as well. And without going into too much detail, there's some pros and cons about interior, exterior insulation on a foundation. We like to keep the exterior insulation all in the same plane. And that's why one of the reasons why we prefer the exterior insulation. It also has to do with how we attach our panels to the foundation. We will bolt through our service layer that I was talking about into the foundation. And if you have the insulation on the inside, then there's nowhere for that attachment to take place.
Anyone else want to touch on foundations?
I can just add, oh, sorry, go ahead, Amelia.
No, you.
Okay. We simultaneously unmuted. I can just add that we, our foundations, as I think most are standard poured foundations. So there's nothing sort of unique or specialized about the foundation itself. It's a very standard foundation in that it uses forms. It's poured on forms as per standard construction. We have done homes that have been placed on ICFs, which is insulated concrete forms. So that's basically creating the foundation form with the insulation itself out of little building blocks. So there's really different approaches that our homes have taken, but typically there's just nothing specifically specialized about the foundation that's necessary to support a panelized or a modular home. So, and then we insulate as per similar specs to Mark was describing, where if you have a foundation, if you have a full foundation basement or crawl space, which most modular homes do, because you need to be able to get underneath the modules to make the connections between the modules. But in any case, they're all insulated and incorporated into the thermal envelope. So it's gained square footage too, if you opt to go that route. So you get more lower cost space that you could finish out as well.
Good point.
And at Geologic, we can do basements, but we really just want to do slabs, and we want to do super insulated slabs. Our slab detail has, it's a lot of EPS insulation around the perimeter, and it also has a air barrier system below the concrete. So our below ground insulation envelope detail mimics our above ground insulation detail. And we just find that it's simple for general contractors to do. We provide the foam forms for the slab foundation in our shell package, and we deliver them to the site when they're needed. And then the nice thing about a slab is that it can double as a finished floor for folks, which can save some money.
Thanks. We have a question about somebody who has multiple chemical sensitivities and is particularly interested in the idea of building with SIPs and wonders what types of chemicals are used, if that's something that might be an option for them. Do you want to take that one, Mark?
Yeah, so, the SIPs are structural insulated panels that, traditionally have been made with injected foam. But, all three of our companies are, trying to limit the amount of foam that we use. And I believe that we all use dense packed cellulose insulation in our wall panels. So our, panels are not the traditional SIPs with the injected foam in the middle. They use the cellulose, which is recycled newspaper, essentially. And so it is a low VOC material. And I know, for us, all of our material, everything that we use in our house has to be considered low VOC. And, we do, like I mentioned, try to pay very close attention to that indoor air quality, and the off-gassing of the materials is a big part of it.
Nice. All right. Anyone else want to add to that, or shall I move on to the next question? We're good. This person is looking to learn about the best heating and cooling options for high performance homes. What do you recommend? I think
Mark,
you're muted.
You can go ahead, but I suspect most of us will universally say a very similar thing, which is air source heat pumps are generally accepted as really the best approach to a high performance home in terms of cost, in terms of energy efficiency, and in terms of long-term maintenance and care. In decades prior, geothermal was popular because the air source heat pump technology wasn't quite advanced enough to handle the lower climate zones or lower temp climate zones. But in the last 20 years, their capacity to operate in really low temperatures has substantially expanded. And we have many homes as test cases that have been performing exceptionally well using that technology for heating and cooling.
There was a question about whether anyone's used a masonry heater in any of your homes. Is that something that you've had experience with?
We actually did have recently a house that has a masonry heater. We try to recommend it against having combustion inside the house, especially wood stove. Many of our clients still, insist on having it either as a backup source or ambiance. But in a airtight, high-performance house, there are two things. You have to make sure that you provide combustion air, because that house is so tight, it's not going to be able to draw that combustion air from inside. So you have to duct it from the outside. And what we tell our clients is you can have a wood stove. You're going to open up your windows when you have it on, but go for it because it'll easily, cook you out of the house if you, with the insulation and the airtight levels that we have.
I'll put a plug in. Also, Parlin did an article on this topic in our fall magazine that came out last fall. So if you're interested in learning more, that's on our website. This is an interesting question. Somebody asked if it's possible to have a second floor addition to a ranch built offsite. So they have an existing home, a ranch, and they're wondering about whether you can work with them for an addition to put on a second floor.
I would say that's a complex question, probably for any of us, primarily because you're marrying two very different construction approaches and two very different wall assembly performances. So, and you know, in the case of where the exterior plane or the exterior structural plane lands, there's alignments there that might become a little bit complex. Certainly it's been done with modular. It certainly can be done with modular. Again, you get into the question of the outcome of the performance of the final home, the finished home, given the differences in approach from the existing home to the newer construction. And then the other question would be the load paths and engineering of what the structure is underneath that second floor and how and whether that would be sufficient to support the loads of the structure you're building above. But in a purely abstract and vacuum hypothetical sense, yes, it is possible.
Anything to add to that on a panelized, from the panelized perspective, Mark?
Yeah, we just say, unfortunately, for Unity homes, we would not do that. We don't do additions, and for many of the reasons why Parlin just mentioned. But I agree with her. In theory, it's possible, just not with Unity homes.
Yeah,
we look at retrofits where we haven't done one yet, but we've looked at them where you build an exoskeleton for the envelope. It's not maybe structural, and that would maybe allow you to do the first floor where you're taking the old windows out and putting new windows in the new part of the structure, which wraps the existing building. And then you take the roof off and you build it up. There's a way to do it. It's complex, and it's maybe not, the driver can never be financial if that's the project goal. So
I heard about a similar project that was being done on scale in Europe to renovate apartment buildings using that approach. All right, somebody has a question on what kind of products would work well in a post and beam construction. Is that an option for modular, for panelized?
Yeah, so I can say Unity homes, many of our designs incorporate elements of post and beam. It works well with the panels for being able to support floors and roof panels and things like that. They're not fully timber framed. Actually, our sister company Benson Wood, that's something that they do all the time, to build full timber frames and then use our panels to finish off the exterior.
That makes sense. As soon as I asked the question, I realized that you were a natural for that. Let's see, what else do we have here? Can you give a short overview of site location and preparation and what is ideal? What are you looking for?
Flat, simple, and ledge-free. But to give a few more points of context, for the high performance approach, an orientation to the backyard that is south is more optimal, in that it's not a requirement, but if you, all things being equal, if you can choose a site that has the orientation on the south side to the back, you're more inclined to really fully engage with the advantages of those large windows and take advantage of those solar gains and the orientation that we're looking for the performance of the home in general. Meaning your biggest open windows, your biggest exposure of glazing is not to the street and to a side of the home where you might be inclined to use blinds or window treatments and detract in some small degree from that solar gain from the home. So that's an orientation question. Generally speaking, it's advisable to be closer to the road just from a cost standpoint. You're not trying to trench electrical or water or infrastructure in general down a long distance or a long driveway. And then from the standpoint of staging for offsite construction, you will want the ground to be prepped appropriately to bring in the heavier equipment for setting the equipment. But for the most part, it doesn't generally exceed the prep and laying down of appropriate supports that's necessary for most construction anyway. You're going to be bringing in large trucks, you're going to be making deliveries. So there isn't too much that goes above and beyond a typical prep of a site for construction. Access, larger truck access is important to sites. So low overhead bridges or narrow bridges, or, you know, narrow openings in stone walls with tight turning radii. Those are considerations, but again, nothing that is egregiously above and beyond what's typical for most construction sites.
I'm seeing nodding heads. Anything to add to that? There's
I think she covered it well.
okay. There's several questions here about getting the right team in place. So one has to do with whether you have realtors that you would recommend to help someone buy appropriate land. This person said she doesn't know where to start. I often would suggest looking for someone who has a green realtor certification as a good place to start. Are there other tips that you would add to that?
Yeah, that's a great place to start, Heather. I mean, it's we have some folks that we've worked with and that have approached us and have a clear understanding of high performance, but yeah, it can be really dependent on where you're looking and what region you're working in. So as far as reference points, I think the green certification is a good place to start.
Great. Lots of people asking where to find someone who does what you do where they are. So someone asking, how do you find a contractor? We have someone from Michigan, someone from Situate, Mass. Any recommend? It sounds like several of you cover at least the Massachusetts region, and Michigan's potential for you, Mark. A little expensive to ship, but any advice for these folks?
Yeah, there's a few things that you can do. We have contractors that we've worked with before that we can recommend. Outside of that, there's a lot of resources locally, Better Business Bureau. One thing that we recommend is go to your local supply house and start asking them, asking friends that have built. There's a lot of different ways that you can sort of vet and, find good quality contractors. For us, once you've found a contractor that you feel comfortable with, we work with new general contractors all the time. So we have a good process for onboarding them and getting them up to speed on the specifics of our details. And, the majority of them that we find that if they don't have a background in high performance, they know that it's coming. So they're usually interested in working with us and interested in learning about it.
Yeah. So at Geologic, our design process takes a little while. Most people, it takes 4 to 5 months to go through that process. And most of our clients don't come with a general contractor partner before we get started. So we end up, networking to find a local general contractor who has a little bit of experience with high performance, maybe not experience with our panel system, but mostly it's quality of construction, price point, schedule availability. These types of things are what end up determining who gets hired. And then we have a little, network of folks who we've worked with before who we can draw on as needed.
Yeah, similar scenario for us. We've got a bunch of builders with whom we've worked, to whom we'd be happy to make referrals. We do onboard new builders on a pretty regular basis as well in new regions. We've done homes throughout the Northeast and into the Mid-Atlantic. So I saw a question about Maryland. We have done a project in Maryland. And it just, how deep the bench of existing general contractors with whom we've worked in the past depends on where it is. And, to add to some of the resources that Mark was speaking to, there are also some good resources specific to high performance building. There's different organizations out there that can help that have lists of rosters of their membership, who many of whom are builders. So Northeast Sustainable Energy Association, or NESE for short, is a great resource for finding experts in various aspects of the built environment. And then the Department of Energy also has, like Energy Star and lists of builders who have subscribed to and adhere to the principles of some of the other high performance mechanisms. There's passive house groups throughout the country. So there are various resources that can be tapped by looking at the membership and the rosters of those organizations that are based around the principles of high performance.
Those are great. I'd be remiss if I didn't also mention the Green Homes Business Directory. So if you're looking for professionals here in Maine, that's also a great place to look. And then maybe another tip, if you are outside of the region that this group serves, it seems like performance building supply and building performance type stores are also a good place to start, because they're working with people in this industry. So if you're outside of this geographic area, you might look for one of those stores in your region. Question for you, Mark. You touched on this in your presentation a little bit, but if you have anything else to add, the question was, can you talk about the delivery? I think it says, can you talk about delivery of a utility home? I think they meant to say a unity home, and any geographical limits.
No, as I mentioned before, we can go anywhere. Outside of the Northeast, the shipping costs, start going up. If we get too far down south, honestly, the high performance level is less effective in, the Southwest or Southeast, the hot, warm climates. But in theory, so our sister company, Benson Wood, has built a house in every state except, I believe, Oklahoma for some reason. So again, it's certainly possible. And, it depends. Just as a quick example, the house that we built in Wyoming, obviously shipping costs were pretty high for that. But that particular homeowner, their location, could not find a builder, that would work within his time frame. And so it just made sense for him to contract with us to deliver that shell. And then he was acting as his own general contractor to get it finished off. So there are situations outside of the Northeast where it does make sense.
Question about windows. Are you able to get a better grade of higher performance windows and doors for lower costs with an offsite built house versus a stick built home?
I'll jump
Seems like
on
it's
this
all part of
one.
the package, right?
Yeah, it's all part of the package. It's essentially, the material costs are the material costs. I think there's a perception in the industry that offsite, and particularly modular, is just inherently cheaper. But all things being equal, if you have the same apples in the bag, they generally cost about the same. Now, there are some efficiencies, certainly in less wastage of material goods because you're sourcing to a single location, and also some advantages in bulk purchasing for specific kinds of products. So on a narrower margin, yes, that is possible. But as far as there's not as much, particularly in the windows, there's not as much like discounting just because it's being built in a factory versus shipped direct to the site. So that's our experience, is that apples to apples, comparable homes cost about the same in straight up material costs. Sometimes there are savings in shorter construction times, and certainly a savings also in terms of the lender structure and some of the interest rates and fees around length of loans.
Great. It looks like we have one last question here, and then I think we're just about at time. And this one is about best practices and methods for insulating vaulted ceilings. Not sure. Do you have any designs where that would apply? Doesn't seem specific to offsite, but anything to add on that?
You know, there's a number of ways to accomplish that. I think the one thing that offsite construction has an advantage in is that we can deliver insulated panels that create that vaulted ceiling instead of having to try to blow in some sort of insulation or fit insulation in on site. So very easy to do with offsite construction, and I think panels that are insulated in a factory and assembled on site do have an advantage over site insulation in that particular application.
And I did have just one more question come in about our wood fiber manufacturer. So do you anticipate the cost of wood fiber insulation decreasing with the domestic availability from Timber HP, who, for those of you who don't know, is our new wood fiber insulation company that is has just launched here in Maine?
Short answer to that is yes. And we are all, I think, in this room, extremely excited about it.
Nice.
So yes.
Fantastic. Well, it looks like we have come to the end of the road. Thank you all. Once again, thank you to everyone who joined us tonight for this episode of Home and Energy Chats. I hope you learned some new information. I do want to mention that all of our panelists have agreed to share their contact information if you do have any questions that come up after the presentation or that we didn't get to tonight. We'll be sending a follow-up email that has everyone's contact information. It will also have a link to the recording from tonight's presentation. Thank you again to our sponsors, Royal River Heat Pumps and Senecal Construction Services, and to Rain Rayner, who has handled everything so beautifully behind the scenes on the webinar tonight. And especially want to give my heartfelt thank you to our panelists for sharing all of your expertise. And we are very fortunate here in Maine and in New England to have so many leaders who are on the cutting edge of these technologies. So I really appreciate you being here and I appreciate everything that you're doing to move this space forward. Lastly, you will see a brief survey pop up when we close the webinar. We'd love your feedback on how it went and also any ideas you have for future programming. And I think that is it. So thank you again, everyone. I hope you have a wonderful evening. And our next episode, I should do a little plug for our next episode, which is going to be about backyard composting. And that is coming up in 2 weeks on April 31st. So 2 weeks from tonight. Thanks again.
Thank you.
Thank you.
Bye-bye.